All right, this is exam 2 review. So these are review problems for exam 2. Now, your exam only covers chapters 2 and 3, but the last page of this review is on properties of exponents, which we covered in 4.1. That I will do it in this video, but it won't be on your test. But nevertheless, I'll still do it anyway. Alright, so these are the kind of problems you can expect on your second exam. So let's look at them. Alright, so one of the first things we talked about in chapter 2, or one of the things we talked about was function notation, right? So f of x equals negative 4x plus 7. So we evaluated functions, right? So this means evaluate f at negative 3, right? So wherever you see x in your function, you're going to replace it with the input. And you're just going to do some computation and see what you get. So just replace that with x, you get negative 4 times negative 3 plus 7. And when you do that, you're going to get 12 plus 7, which is 19. That's your output. So you're done. That's it. It's as easy as that. Evaluating functions, you just plug in a value and see what you get. In letter B, we're asking you to find the input when f of x equals 2. So in this one, you don't want to input. Don't do this. Don't do that. What you want to do, because this implies that x would be 2, but that's not what I'm saying here. I'm saying find x when the function equals 2. So what you need to do, what you want to do, is take the function and set it equal to 2. Your function is negative 4x plus 7, and that equals 2. Now you just solve for x. Subtract 7 from both sides. Negative 4x equals 2 minus 7 is what? Negative 5. And then divide both sides by negative 4. And when you do that, you're going to get x, right, equals, now this is positive 5/4. And that's it. All right, number 2, you're evaluating this function when your input is a minus 3. So, like we talked about in chapter 2, your input doesn't just have to be a number. It could be an expression. So what you're doing is you're taking h and you're evaluating at a minus 3. So wherever you see x in your function, just replace it with a minus 3 and then simplify it. So you're going to have 3 times a minus 3 minus 4 in the numerator, and 5 times a minus 3 plus 2 in the denominator. Now you're just going to distribute the 3. You're going to get 3a minus 9 minus 4 over, and you're going to distribute the 5. You're going to get 5a minus 15 plus 2. Combine like terms in the numerator, so 3a, minus 9 minus 4 is minus 13. And 5a minus 15 plus 2 is what? 17. Oh wait, I'm sorry. Negative 13. My bad. Sorry about that. I wrote positive 15 by accident. So just distribute the 5 here. 5a minus 15. Minus 15 plus 2 is minus 13. So now, you know, don't make this simple mistake. Don't do this. You know, it's very easy to assume that you're going to cancel the negative 13s here. Don't do that. The negative 13s do not cancel. That's as far as you can go. That's it. You can't cancel those 13s there. You know, you'll learn later on in the class when we look at, this is called a rational function, and we'll look at those later. I think we look at those in chapter 8, but just be aware that you cannot cancel the 13s out here. That does not become 3a over 5a. All right, that does not become that. And then, so this is as far as you can go. That's your result when you plug in a minus 3 into this function. That's what you get. All right, page 2. So here's a modeling problem. I did say I would put one on the exam, and I can, you know, I said it's very likely you're going to see a modeling problem in the test. So the percentage of U.S. teen drivers with driver's licenses are shown in the table below. Okay. So percentage of U.S. teens with driver's license. So here's the age, and here's the percentage of the age that have driver's licenses in the United States. We're letting P equal the function f of a. So P is the percentage of teenagers age A years who have driver's licenses. So my independent variable is A, that's the age, and my percentage P is the dependent variable. All right, so question A is to find the equation by hand. Okay, so in order to do this, what do we have to do? We have to make a scatter plot because we want to make sure that we pick two good, remember we use interpolation? We want to use two good points that give us the best equation by hand. And that's what I mean by hand, is we want to use interpolation. Alright, so we got to make a stat plot, right? So turn your stat plot on, second y equals, turn that one on. Alright, now go to stat, edit, clear that list, type in your data. So A is the age. So that's the data that's given to us. That's the data is the same as the variable's description, so just type in the data for age, 16, 17, 18, 19, 20, in column 1. Column 2 is the percentage of teenagers who have a driver's license, and that's the data, so type that in L2, 56.8, 61.3, 72, 79.4, 81.4. Okay, I'll just put 72.0 there. Oh, okay. So there is my data. I'm going to make sure y equals is clear. And now to plot my scatter plot, go to zoom stat, which is at number 9. And there's my scatter plot. So based upon the scatter plot, it seems like, now remember, when we use interpolation, we don't pick the first or second ordered pair, right? We ignore those two. We want to choose 2 from the 3 in the middle, right? So based upon this, it looks like, now I don't want to choose the first and second one together, but I could choose the second one and well, it doesn't look like any combination of 2, 3, or 4 is going to look. I mean, they'll be okay. It's just they won't be very accurate. But you know, you could choose any 2 of the 3 inner points that you want. You could pick this one and this one. You could pick that one and that one, and any combination you want. I will pick the second one and the fourth one. Again, that's up to you. You could choose the 2, and you could choose the second and third one. You could choose the third and fourth one. You could choose the second and fourth one, like I just did. That's up to you, just as long as it's not the first and the last, because that would not be interpolation. So the second one is this ordered pair, 17, 61.3, and the fourth one is 19, 79.4. So when I find the linear equation, I have my 2 ordered pairs. I could find the slope. Right? Now, y in this case is p. So this is p2 minus p1. X in this case is a. That's the age. So that's a2 minus a1. So when I do that computation, I get, so P2 is 79.4 minus 61.3 over 19 minus 17. Alright, so let's whip out our calculator. So 79.4 minus 61.3 gives us 18.1 in the numerator. 19 minus 17 gives us 2 in the denominator. So when I do that, 18.1 divided by 2 gives me 9.05 as the slope. And if I use point slope form, that would be y minus y1 equals the slope times x minus x1, right? But in this case, y is p, x is a, right? So y, this will be a minus a1, or I'm sorry, that's p minus p1, my bad, equals m times a minus a1, right? Come up here. So p minus p1. So now I could pick the order pair to be here. I could pick those order pairs, you know, just as long as I pick either this one. I have to pick from the 2 that I used, not from the data. Just be careful about that. Remember, we did that in class. You got to pick from either this one or this one, but not the other ones. I'll pick the first one. So p minus 61.3 equals 9.05 times a minus 17. Alright, now I just gotta do a distribution here. So 9.05a minus, and 9.05 times 17 is 153.85. Add 61.3 to both sides. So then P equals 9.05a. So minus 153.85 plus 61.3 is negative 92.55. So let me write that over here because that's a little tight. So P equals 9.05a minus 92.55. And that right there is my equation by hand if I use the second and fourth point. All right. I could graph that in my calculator, and y equals 9.05 x minus 92.55. Graph, and there it is. Now you can tell that that linear model doesn't do a very good job, right? Because this data point's kind of out there. This one is a little out there too. It's pretty good. I mean, it's okay, but it's not the best. So in letter B, I ask you to find the linear regression equation using your calculator and to use function notation. So the function notation's right here, right? That's the function notation, f of a. So your function's going to be f of a equals some linear, some linear equation. So the linear regression equation, that's the line of best fit. So you got to use your calculator for that. That's the only way we did it. We don't do that by hand in this course. So to do that, you're going to go to Stat, over to Calc, and then LinReg. You're going to go down to Calculate, and hit Enter. And there it is. So remember, if you have a TI-83, you won't see, let me do that again, you won't see this page. Remember, if you look in your notes, when we did this, I think it's 2.2 or 2.3. Just look in your notes to see how we did it if you had a TI-83. You have to type in the you have to go to LinReg, hit enter on that, and then you would type L1, comma, L2, and then you would hit enter. That's if you had a TI-83. Just look at your notes to see the way we did it. So I'm going to go down and calculate. So there is our linear, and remember, this is the linear correlation coefficient. That talks about how linear it is, right? It's between -1 and 1. This one's 0.97, so it's pretty linear. It's pretty good. So my line of best fit is f of a equals my slope, which is 6.73. A, and my y-intercept is -50.96. That's my linear regression equation. This is the line of best fit. If you want to graph that in your calculator, go to y equals. I could go down to y2 and do that. Let me make this one bold just so it sticks out. And then let me type it in. So 6.73 x minus 50.96. Graph it, and there it is. There's the linear regression, and you can tell that that one is much better. That one comes as close to all the data points as much as possible, and nothing's going to get closer than that. So there's the linear regression equation. Okay, so find the A-intercept. So what does it mean in this situation? So when I say this, you're going to use the line of best fit, obviously. You're going to use the line of best fit because that's the best possible model, right? That gives you the best approximation. Okay, so find the A-intercept. What does that mean? That means you want to find A when the other variable, P, is equal to 0. Well, P is what the function is equal to. So what we're saying here really is, what we're really saying is when the function is equal to 0, right? So, because we're using function notation here. P is equal to the function at the input. Dependent equals f evaluated at independent. That's the function notation, if you remember from your notes. So just set this equal to 0 and solve for A. to find the A-intercept. So when I do that, I get 6.73A minus 50.96 equals 0. Add 50.96 to both sides. .73A equals, they cancel, so I get 50.96. Divide both sides by 6.73. So A equals, so 50.96 divided by 6.73 gives me 7.57 if I round that to 2 decimal places. So my A-intercept is 7.57, comma, 0. What does it mean in this situation? What does it mean? So, if you remember, this is the t coordinate, right? I'm sorry, not t. This is the a coordinate. This is the p coordinate, right? This is a. This is p. Right? That's my ordered pair. So, a represents what? That's the age years who have a driver's license. So if a is 7.75, what does P represent? That's the percentage of teenagers that have it's the percentage of U.S. teenagers with a driver's license. So this is the percentage, and this is the age. So if I interpret this, this means 0% of U.S. teens with a driver's license .0% of U.S. teens with a driver's license in the U.S. I said U.S. are 7. I guess if I rounded that up to 8, right? So I could say are roughly 8 years old. Now, I know I don't ask this, but obviously this is model breakdown. That is model breakdown. I don't ask you that here, but I may ask you that on the exam. You know, it's model breakdown because, well, it's not likely an 8-year-old. Well, first of all, an 8-year-old isn't a teenager, and second of all, 8-year-olds aren't legally of age to get a driver's license. The legal age to get a learner's permit is, I think it's 15 or 16, I don't know. But you can't get a driver's license until you're roughly 16. So, yeah, obviously that is model breakdown. Okay, so if I go on to the next page, question, going to the next page. So this problem still continued. And letter D, I say estimate the percentage of 21-year-old adults who have a driver's license. Okay. So when they're saying this, estimate the percentage, that means they want you to find what is P of 21-year-old adults. So what is P? All right. When A, because that's the age, right? When A is 21. So to do that, just plug it into your function. So f is at 21, right? And your function was 6.73 times 21 minus 50.96. So if you do that computation, you get 6.73 times 21 minus 50.96 gives you roughly 90.37. So how many 21-year-olds in the United States have a driver's license? Roughly 90.3%. And that's a realistic result, so that's okay. So this means roughly 90% of 21-year-olds in the U.S. have a driver's license. All right. Letter E. Estimate at what age all adults have driver's licenses. So they're asking you at what age. So that means what is A? When all adults have driver's licenses. So what percentage implies all? That implies 100%, right? So they're saying what is A when the percentage, if I'm talking about all, I'm talking about 100%. What is A when P is 100? So my model, my line of best fit, is going to be equal, right? P is 100. This means f of A is equal to 100. So I'm going to set my model equal to 100, and I'm going to solve for A. So 6.73A minus 50.96 equals 100. Add 50.96 to both sides. 6.73A equals, so 100 plus 50.96 gives me 150.96. All right. Divide 6.73 by both sides. So 150.96 divided by 6.73 gives me roughly 22.43. So at what age do all adults have driver's licenses? Roughly 22, or you could say 22. It's 22.4, so I could round that down to 22. Roughly 22 years old is when all U.S. adults have a driver's license. Now, this is model breakdown. And why is it model breakdown? Because, you could probably do research. I'm sure there's definitely 22-year-olds out there that don't have a driver's license. I mean, just off the top of my head, I could think of a few people who are in their 30s that don't have a driver's license. So obviously, 22-year-olds, not every 22-year-old has a driver's license in the United States. That's just, just because you're old enough to drive doesn't mean you're legally able to drive. So, yeah, I mean, a lot of people live in big cities and they rely on mass transportation and they never had to get a driver's license. So, yeah, that's definitely model breakdown. Now, again, I don't ask you if model breakdown in this question, but I may on the exam. All right, number 4, solve the following system. So when you're doing this, again, you have two choices. You have substitution or elimination. Now, obviously here, you're going to use elimination, because if you're going to do substitution there, you're going to remember you're going to get messy numbers. You know, sometimes substitution is going to get ugly, like you're going to get fractions, and I want to avoid fractions. So let's use elimination. Let's use elimination. Okay, so I want to multiply one of these equations or both of these equations by a number so that when they add together, one of the variables cancel. So if I'm looking at this, well, let's say I want to get rid of the x's. Try eliminating x. Alright, so to do that, I want to think of a number to multiply this by and a number to multiply this one by to get the x's to cancel when they add together. So, you know, that's up to you. Well, the common factors between 4 and 6 are 24, right? So I can multiply the first equation by -6, right? I can multiply the first equation by -6 so that this becomes -24x. And to get positive 24x here, I could just multiply the second equation by 4. Alright, so now when I do that, what do I get? Multiply the first equation by -6, I get -24x. -6 times positive, or -6y is positive 36y. And that equals -30. Second equation becomes 24x. 4 times -9y is -36y. And 4 times -2 equals -8. Okay. So now what? Well, if I add these equations together, just give me 1 second, guys. So if I add these equations together, -24x plus 24x, sorry about that, I was doing some basic computations, they cancel, right? You're going to get 0, right? Uh-oh, when I add 30y, or 36y, and -36y, they also cancel. So they cancel, and they cancel there. So I'm going to get 0 on the left side, and that equals, so -30 plus -8 is -38. So both of my variables, not only did x cancel out, Y also canceled out when I did that. So what does that mean? Well, it doesn't mean we did something wrong. It just means that this solution, so this is a false statement. Right? That's a false statement. So if that's a false statement, what that means is that this is an inconsistent system. Which means what? That means they don't intersect. If you were to solve both of these equations for y, they would have the same slope, which means they don't intersect, which means the solution set is empty. There is no solution. So, you know, just because you get this doesn't mean you did something wrong. If you remember that when we covered the notes, I talk about this in chapter, I think it was chapter 3. When we did systems of equations, I talked about if you get a false statement, that means you have no solution. So, yeah. So this one doesn't have a solution. Okay. So that was page 3. Let's go on to page 4. All right, so in this one I have the winning times in seconds for women and men in the Olympic 500-meter speed skating race. And they're modeled by these linear systems, where T is the number of years since 1970. So when will the women's time be the same as men's winning time? And what will that time be? So that right there, when will they be the same? Right, the word same right there, that implies I got to do what? It means that I have to set these two equations equal to each other. And then solve for T. And that'll be when they are the same. Because that'll give you the value of T, which is the number of years since 1970. So you'll just tack that value on to 1970, and that'll be the year. So let's do that. Now you could do this in your calculator by finding the intersect feature, right? And I'll show you that. So let me turn my stat plot off because that'll just make it weird. Get rid of my equations. So let me type in negative 0.153x plus 43.19. Y2, negative 0.135 x plus 39.64. And that's in Y2. And let me make this one bold just so I know which one is which. Okay, so those are your equations in the Y1, Y2. All right. I'm going to graph them. Now I might have to adjust my view. That's fine. We do that a lot. So window. Let me pick some values here. Negative 100 to 100. Negative 100 to 100. There's the first one, and oh, so close. Let me go to zoom, and I'm going to go down to zoom fit. That'll auto adjust it. Sometimes that works, sometimes it doesn't. There's the first one, and ugh. All right. Let me zoom out. Getting better. All right, let me scroll down the line here, and let me zoom out from down here. So with the cursor there, it's going to zoom out with the center of the image right there. So if I go to zoom and out, it'll zoom out from this center point. So basically it just shifts it so that's in the center there. And I have a better view of my intersection. Alright, so my intersection point takes place somewhere around here. Alright, so we'll figure that out later, but let's look at this by hand. You know, we'll verify our work with the calculator in a minute, but since you know how to do this by hand, you're going to obviously do it by hand. So W of t was equal to negative 0.153 t plus 43.19, and that equals the men function, which is negative 0.135 t plus 39.64. Bring the t's to one side, so let me add them to one side. Oh, my camera is being really stupid. And let me subtract 43.19. So that cancels. That cancels. So the left side becomes negative 0.153, negative 0.153 plus 0.135 gives me negative 0.018 t. And that equals 39.64 minus 43.19, negative 3.55 on the right. Divide both sides by negative 0.018. T is going to be equal to, so this number divided by negative 0.018, 197.2. So I'll round that up to 197. So remember, this is the number of years since 1970, right? So if that's the year since 1970, you're going to add 197 to, so 1970 gives you the year 2167. So when will the women's time be the same as the men's time? Same time, same winning time in the year 2167. Now, what will that winning time be? So what is the time? So to figure that out, that's what the function measures, right? The function measures in seconds their speed and, well, how long it takes for them to do the 500-meter skating race. So you're going to plug, you're not going to plug the year in, you're going to plug in the number of years, right? You're going to plug that into either the first one or second one. I'll pick the first one. So W at 197 gives you negative. Now you should use the exact value for t. All right, you should use the exact value for t. So 197.2222, you want to use that. That would give you the best approximation, but if you don't, you can use the rounded value. It's not a big deal. Just realize that it might be off a little bit. So if I want to use that, I'll store this into x. So I'll store into X. And now I'll just type in W. So W is negative 0.153 times 197 plus 43.19. So if I do that with the exact value, right, let me type negative 0.153x plus 43.19. And that gives you 13.015. So, according to this, what is that winning time? Well, the winning time will be 13.015 seconds. Now, that's pretty, that's pretty fast. Now, let's just go back to our graph here and see if that is the intersection point. Right, the order pair which should be 197, 13.015. So it should be relatively close to that. It should technically be 197.222, 13.015. So remember, to find the intersection point in my graphs, I go to Second, Calc, Intersect. Pick a point on the first curve, hit Enter. Pick a point on the second curve, hit Enter, and then hit Enter again. And there it is. 197.22, 13.015, which is what we got. So there's the X value, or the T value, and there's the Y value, or the winning time value. So yeah, this is obviously model breakdown. Even though I don't ask that, that is model breakdown, because unless they're going at the speed of light, I don't know how they're going to finish a 500-meter speed skating race in 13 seconds. That would be pretty impressive. Okay. So this is a word problem, right? So when I do these problems, I typically use a table. I'll make a rough table here. Probably more than I needed, but whatever. But since I'm a perfectionist, I gotta cut it off a little bit. Alright. So, what we're trying to do is figure out, so what's the unknown here? Right? What should the prices be for each type of ticket? That's the unknown. So this is a total value problem, right? So remember, the way we set up the tables is the quantity goes in the first column. This is the number of tickets. This is the price per ticket. And this last column is the total value of tickets. Right? What kind of seats do we have? All right. Well, we have main level seats, and we have balcony, and we have a total. Right? So there's a rough table. So what should the prices be for each type of ticket? So since that's the unknown, we got to give them a variable, right? So we're going to let X be the price for a main level ticket, and we'll let Y be the price for a balcony ticket. All right. So since those are identified, now I can put them in my table. The price per ticket for a main level ticket, we let it be X. Price per ticket for a balcony ticket is Y. Alright. What's the number of tickets for main level? Alright, so the balcony, right? The balcony has 360 seats, right? So there's 360 balcony seats, right? And there's 1,200 main level seats, right? Okay. Now remember when we did these problems, this was like, I think it was 3.4, section 3.4. When we did these problems, I always ask you if there's a description of variables in the problem. And if there is, that would mean there's only going to be one equation from this table, right? So if I look here, if tickets for balcony seats will cost $10 less than tickets for main level seats, that right there is a description of the variables. Since that's a description of the variables, that means I'm going to get one equation. So I want to write that description here. I want to write the relationship between X and Y. So what's going on here? We're saying tickets for balcony seats. All right, so Y is what? Tickets for balcony seats will cost $10 less than tickets for main level seats. So if I'm charging X dollars for main level seats, and balcony seats will be 10 less than that, so that'll be X minus 10. So balcony seats will be $10 less than tickets for main level seats. So that's where this piece of information comes from right there. Okay, let me fill in the rest of my table. So remember, how do we get the third column? We multiply the first and second column together, right? The number of tickets times the price per ticket equals the total value of the tickets. So 1,200 times X is 1,200X. 360 times X minus 10 in parentheses, right? Don't forget those parentheses. And the total value of selling out the theater will be, right, a sellout performance will be $33,840. So my equation, and I'm only getting one because of this relationship right here, is this column. So my equation is going to be 1,200X plus 360 times the quantity X minus 10 equals 33,840. So to solve that equation, distribute the 360. So 360x minus 360 times 10, well, negative 10 is minus 3,600. That equals 33,840. All right, combine like terms. 1,200x minus 360 or plus 360x is 1,200 plus 360 is 1,560x. Add 3,600 to both sides. They go away. 1,560x equals, so 33,840 plus 3,600 is 37,440. Divide by 1,560. So 37,440. Let me show my calculator. Divided by 1560 is 24. Good. So that means the price. So the answer should be what? You should charge 20. So X is 24. That's the price per ticket for main level tickets. So you should charge $24 for a main level ticket. And you should charge what? So how do you get Y? Well, Y is just X minus 10. So that's going to be 24 minus 10, $14 for a balcony ticket. And that's it. So 14 for a balcony ticket and $24 for a main level ticket. All right, let's go on to page 5. So linear inequalities. These are the last things that I could ask you on your exam. Solve the linear inequality, describe the solution set on a number line and an interval notation. So again, the algebra for this is it's identical to a linear equation. The only thing different is the solution set is a set of values. So to solve this, let's distribute -3 and -2. -6x minus 3 minus 2x minus 8 is greater than 0. Alright, -6x minus 2x is -8x. -3 minus 8 is -11, which is greater than 0. Add 11 to both sides. -8x is greater than 11. Divide both sides by -8. So remember, when you divide it or multiply an inequality by a negative number, you have to flip the inequality. So this greater than becomes less than -11/8. X is by itself, so this is the solution. To write it on a number line, all right, I always put 0 on my number line. That's just me. To put negative value on the left. So this means X is less than this value, -11/8. So everything to the left of that's going to get shaded. And that goes on forever and ever. Now the value -11/8 itself is not part of this because I don't have an equal sign. This is just less than. That's just less than. So I'm going to have a open circle to indicate it's not part of the shaded region. Okay, my interval notation. So always start with the smallest value on your shaded region, on your interval. The smallest value on here, so I go to the left forever, right? That's going to be -infinity, comma, up to my largest value, which is -11/8. Now I just have to put a bracket or a parenthesis on the endpoints. All right. Well, infinity is always open because it never stops, whether it's positive or negative infinity. And since -11/8 was not part, it's only less than, not part of the shaded region, that's also a parenthesis. That's my solution set in interval notation. So this one right here in letter B, this one's a compound inequality. So whatever operations you do, you have to do to all three sides. x is going to be caught between two values. So let me subtract 1 from all three sides. So when I do that, I'm going to get 3/4 minus 1, which is going to be negative 1/4, is less than or equal to negative 1/4 x, right? Because the 1's cancel, which is less than 3 minus 1, which is 2. Now I have a negative 1/4 x. So to get rid of that, I want to divide all three sides by negative 1/4. Okay. So that cancels. Now, my x is still in the middle, but remember, we divided by a negative number. So the inequalities are going to flip. So negative 1/4 over itself is 1. This less than or equal to becomes greater than or equal to. 2 over negative 1/4, well, that's the same thing as 2 times negative 4, which is negative 8. Or you could just type it in your calculator, whatever you want to do. 2 divided by parenthesis negative 1 over 4, close parenthesis, is negative 8. Right? So that's going to be negative 8. And this is going to flip. Right? Now, this is correct, but whenever I write an inequality, I always write it from least to greatest value. Always. So the way it's written now is not in least to greatest value. So I want to reverse this. So the smallest value goes on the left, and since the open end is pointing towards the x, I'll keep it that way. And then, since the open part is pointing towards the 1, I'm going to keep it that way. That's the same as this. They're the same. But this is written the correct way. To graph that on my number line, there's 0. Negative 8 is over here. 1 is over here. So 8, or negative 8, is not part of the interval. It's just less than. So I have an open circle there. 1 is part of it because it's less than or equal to, so it's going to be shaded there. Right? And everything in between is part of the interval. All right. Ooh, my camera just doesn't want to focus. All right. In my interval notation, is going to be, so negative 8 comma 1, and it's going to be a parenthesis or a bracket, right? So negative 8 is going to have a parenthesis because it's not part of the interval. It's open there, right? And 1 is part of the shaded region, right? There's an equal sign there, so that's going to be a bracket. And that's it. So that means any value between negative 8 and 1, and any value in between, is going to be part of this solution set to the inequality. As long as it's between negative 8 and 1, not including 8, but including 1, and you plug it in here for x, you'll get a true statement. That's all it means. All right. The last page. So again, this is not part of your exam, but I will go over it anyway. Just because I'm a nice guy. So simplify using properties of exponents. So I'm multiplying these two together. All right. So negative 9 times negative 8, well, that's positive 72. B to the negative 7th times b to the 6th is going to be b to what power? So when you multiply the bases, right, you're going to add the exponents together. So that's going to be negative 7 plus 6. That's the power there. And then c, so when you raise c to the 5th power, so c to the 5th times c to the negative 5th, you're going to add them together. So that's going to be 5 plus negative 5, which is the same thing as 5 minus 5. So 72. So the power of b is going to be, so negative 7 plus 6 is negative 1. And the power of c is going to be, well, 5 minus 5 is 0. Right? So when you simplify this, right, this is all over 1. Right? This is all over 1. So when you simplify this, remember, I don't want any positive, or I don't want any negative exponents. I want this to go down on the bottom, right? I want to flip it to make it positive. So when I simplify that, I'm going to get 72 over b. All right. Now, what is c to the 0 power? Well, remember, anything raised to the 0 power except 0 is going to be equal to, that's going to be equal to 1. So because that's just 1, all I have is 72 in the numerator. That's it. All right. This right here is equal to 1, and that's negative, so I bring it down here to make it positive. That's it. Letter B. So again, everything up here in the numerator is raised to the 4th power. So let me break that up and write that as 2 to the 4th power times b to the negative 7th to the 4th power times c to the 4th to the 4th power. All over. Now the denominator isn't, everything in the denominator isn't raised to a power, so I could just write that as 5 to the negative 1st times b squared times c to the 6th power. All right, so now 2 to the 4th is 2 caret 4, which is 16. And b, so negative 7, so this is a power to a power, so you're going to multiply the powers. That'll be b to the negative 28th. And then you're going to have c, so c to the 4th, that's another power to a power. So 4 times 4, that's going to be c to the 16th power. All over 5 to the negative 1st power, that's a 5, not an s. b squared times c to the 6th. I'm not quite done. All right, I'm not quite done yet because I have negative exponents. I want to make them positive, right? So because this b to the negative 27th or negative 28th is negative, I want to bring it down here. And because 5 to the negative 1st power, I want to bring that up top. So when I do that, I'm going to have 16. Everything else is still a 16 c to the 16th times over, oh wait, I forgot my 5, didn't I? Times 5 to the 1st, right? In the denominator. So basically what I'm doing here is I'm swapping these two. They're being swapped. All right. So I have 16 times 5 times c to the 16th in the numerator, which is what I have. And in the denominator, I have b to the 28th times b squared times c to the 6th. Okay. 16 times 5 is 80 times c to the 16th over c to the 6th times b to the 28th times b squared. Now, I'm just doing, I'm simplifying one thing at a time here, but if you notice things and you want to simplify multiple things in one step, you can do that. That's fine. I'm just doing it one at a time. That's all I'm doing. But if you wanted to, add these exponents together, because that's what we're going to do next, you could do that. All right? You could do that. So what I have is I have 80 in the numerator, right? Now c over 16, or c to the 16th divided by c to the 6th, right? So when you have the same base and you're dividing them, you're subtracting the exponents, right? And since the bigger of the two, since 16 is bigger than 6, the result of that is going to go in the numerator. So c to the 16th divided by c to the 6th is going to be c to the 10th. Right? And that's going to be all over b to the 28th power times b squared is going to be b to the 30th power. And that's it. I can't go any further with that. So again, properties of exponents will not be in exam 2, but you do have a review for it. And I do, just because this isn't on exam 2 doesn't mean you can ignore it. You should definitely still try it, because it will show up on another exam. So that's it for this review exercise, or for the review for exam 1. If you do have any questions about it, you're always welcome to ask me during office hours, or I'll take a few brief questions during class. But that is the review for exam 1. And I really do think that if you just do this, I think you'll be more than fine for the test. Now, that doesn't mean that, I could ask multiple problems of the same type. I could do that, but, you can expect similar problems like that. So, yep. So, that's the end of the video.